Hi, welcome to the channel. My name is Wallace. Firstly, I'd like to appreciate each and every subscriber that has subscribed to the channel, everyone that has been commenting and liking, even sharing the videos that we have been posting. I believe you have been finding this information helpful in your studies. In today's video, we'll be looking at engineering science, and we'll be looking at the hydraulic press. In today's video, I'll try as much as possible to make it short and also to cover at least 2 levels in one video. Alright, so the hydraulic press, there are just a few things that you need to understand about the hydraulic press, and that the hydraulic press is just a machine. And what we know about a machine is that a machine is a device that makes our work easy, that enhances our work or makes work easy for us to do. A simple illustration of it would look like this. Alright, so hydraulic press will look something like this. It will have 2 parts, where you are applying the force and where the force is being received. In this case, I've drawn an object on this part. If we push this this side, if we push this one down, this liquid will be pushed and it will push this object upwards. So this object will go upwards as a result of the force that we apply on that part. Where we are applying the force, where the force is being applied, this side we'll call it the plunger side. Where the force is being received, we'll call this side the ram. So a hydraulic press is just a machine like we have seen. So there has to be somewhere where you're applying the force. There has to be somewhere where the object is being done. Any machine has got all those 2 parts. So the first thing that we need to know is that a hydraulic press obeys the same laws that we've been talking about in hydraulics, and that law is that no matter how much force you apply on that object, this liquid will not be compressed, but what you will create by applying a force will create a pressure in the liquid. So number one thing about the hydraulic press is that the pressure in the liquid, the pressure is the same throughout according to Pascal's law. So this is just Pascal's law. The pressure that we create by applying a force on the plunger, the pressure will remain the same in the hydraulic press. Now the pressure that is created on the plunger side depends on the area of the piston and also the amount of force. So remember, we said pressure is equals to the force over the area. So the area of the piston on the plunger, area of piston of the plunger also, and the force. So the more the force, then the more the pressure. The less the area, the more the pressure. So pressure is directly proportional to the force, inversely proportional to the area. But the pressure that we create in there is the same throughout the system or hydraulic press. So pressure remains the same. The liquid pressure is the same. That's the first thing that we need to know. So now, what we have said is that the pressure that we have created on the plunger, pressure on plunger, I'll use PL for the plunger, is equals to the pressure on the ram. So the amount of pressure that we create, that is the pressure that will push upwards. The pressure that we create on the plunger is the pressure that we receive on the ram. So this, we know that force over area, that is our pressure. So what we have is force over area of the plunger should be equals to force over the area of the ram Okay, so that is what we be looking at. In this case, the force and the area of the plunger, the force received, the force that you receive, this upward force, also now depends on the area. But the pressure in both sides of this machine, the pressure will still remain the same. Now, what we'll be looking at in most cases, they'll give us, this will be a diameter, it's a circle. Therefore, we can reduce our area to say force on plunger is equals to pi, formula for area is pi d square over 4 is equals to force on the ram, also pi d square over 4. All right, I'll use capital letter D for the plunger. I will use a small letter D for the ram. But it doesn't matter which one you use, as long as you can identify which diameter is for the plunger, which diameter is for the ram. But if we work out this, pi and 4 will eventually divide themselves out. What we have is the diameters only. So the force over the diameter square on the ram is equal to the force over the diameter square on the plunger. When you're using diameters, you have to square the diameters. But if you're using the areas, there is no need to square the areas. So the square on the diameter comes in because area of a circle is pi d square over 4, or area of a circle is pi r square. So if you're using the diameter, you have to square. If you're using the radius, you can also square, but we can use this in order for us to compare the forces between the plunger side and the ram side. That is the first thing that we have to know. The second thing that we have to keep in mind is that the force is not the same. The force that we have applied on the plunger, force on plunger will not be the same as the force on the ram. These forces will not be the same, will not be equal because of the diameters. If the diameters were the same, then the force will be the same, but in this case the force will not be the same. So just keep in mind that we are not looking at force, but what is the same in this system is that the pressure is the same, not the force. The force is not the same because the diameters are not the same. All right, then the third thing is that according to liquids, or the properties of liquids, what we said is that liquids are incompressible. The volume cannot be you cannot change the volume by compressing the liquid, so the liquid will remain the same. So what that means is that the volume of liquid that is displaced, volume displaced on the plunger, is equals to the volume that we receive on the ram. Okay, what we mean is that if we push the plunger downwards, let's say this plunger goes downwards and it comes up to this point, all that liquid that was here has been pushed, it will displace, or it will lift up our ram to a certain height. Okay, so the volume that has been displaced, that was there before, has been pushed, and it just pushes the ram upwards. So the volume displaced on the plunger is equal to the volume that we receive on the ram. The volume remains the same, like we mentioned in the earlier videos is that liquids are not compressible. So that's what we said, and that is the principle that is being applied in this case. So now this takes us back to our calculations for volume. If we need to know the volume that was displaced on the plunger, then we need to know what is called the stroke length, the distance that it moves, that the piston moves. This is called the stroke length. Like we've mentioned in the previous videos, that is the stroke length. In calculating for the volume of a cylinder, will be saying the area of the piston times the height, which we talked about to say it is pi d square over 4 times the height. So volume remains the same, which means on this side we can move one stroke going downwards. That one stroke will displace, it will lift our object to a certain height. Again, the height or the stroke length that has been moved here is not the same distance that has been moved on the ram. The distances will be different, also depending on the size. With the height that the ram lifts up compared to the displacement of the liquid on the plunger, this we can just imagine if, let's say, we have a container filled with a liquid, a slim container like that, and a broad container like that. If we take this liquid, place it in this container, the height of the liquid in this slim container will not be the same height that we receive on the other in this broader container. So in the same way, the stroke length on the plunger is not the same as the height that is displaced on the ram. All right, then the fourth thing and the final thing that I want to mention about the hydraulic press, then we'll look at a few questions. The fourth thing that I want us to consider when you look at a hydraulic press is what is called efficiency. Like we have mentioned, a hydraulic press is a machine, and every machine has got what is called efficiency. Like we mentioned in the other videos, efficiency is a ratio expressed as a percentage. It's a ratio between the output and the input. Then we express this as a percentage. So in most cases, when they give us efficiency, this is a percentage. It will be expressed as a percentage. We'll look at questions that involve calculating for the efficiency or calculating with efficiency involved. And then the other thing that we have to consider also on the hydraulic press is what is called mechanical advantage. Okay, so as described, a hydraulic press is a machine. So every machine will also have what is known as mechanical advantage. Mechanical advantage is just how much advantage the machine helps us to have over the load. If I am the one applying a force on this side, that force will be called an effort, because that is what I am applying. But then how much advantage does it give me over the object that we are lifting, which will be called the load? So mechanical advantage is just a ratio between the load over the effort, how much is being applied to how much is being lifted. Then we get that. So mechanical advantage is just a ratio. There are no units for mechanical advantage. It will just be a number. The other thing that we need to consider on a hydraulic press is what is called losses and slip. Like any other machine, a hydraulic press also has got its own failures. It has got its own inadequacies and so on. So it will have what is called losses. It will have also a slip in terms of if we push this downwards, does it lift this to the required height, or does this slip downwards a bit? So there will be all those inadequacies and so on. So with losses and slips, it's still a loss, and all these two will be considered as percentages as well, but these two will be losses, which are failures on the efficiency on the hydraulic press. So with losses, it's just a percentage of how much is being lost, how much of the height is being lost, or it slips by so much. So with a hydraulic press, just like any other machine, it will have its losses and its slip. Alright, so for our first question, the question reads as follows. The following refer to a single acting hydraulic press. The ratio between the diameters of the plunger piston to the diameter of the ram piston is 1:4. So we have a ratio of diameters. Okay, and this ratio is 1:4. So this one represents the plunger. This 4 represents the ram. Now, these are not 4 millimeters or 4 centimeters. This is just a ratio, which shows the relationship between the plunger diameter and the ram diameter. If the plunger diameter was 1 millimeter, then the ram will be 4 millimeters. If the plunger was 2 millimeters, then this one will be 4 times as much as that, 4 times as much, which will be the other one will be 8 millimeters. So that is the relationship that we have. All right. Then the question also says the volume liquid displaced by the plunger per stroke is equals to, so our volume of plunger is equals to 35342,917 millimeter cubic millimeters. The stroke length of the plunger, so height of the plunger, stroke length of the plunger is 50 millimeters. So the force on plunger is equals to 250 newtons. Calculate the force exerted by the ram, the diameter of the plunger piston. All right, so that is our question, and this one does not involve any efficiency and so on. So we'll just calculate this one. So for the first question, what we are asked is calculate the force. Now what we said is that the force on the plunger over the diameter of the plunger, don't forget to square, should be equals to the force on the ram over the diameter of the ram square. All right, what we are looking for is the force that is exerted on the ram. We're looking for that guy. We'll cross multiply. What we'll say is that force on ram is equals to force on plunger times diameter of ram square over the diameter of the plunger square. Okay, that is what we are looking at. So now, like we said, if you look at this relationship, we have our force 250 times the diameters, but we do not have diameters. Instead, what they have given us, it is a ratio, which is just a relationship. If you choose to say, I will use numbers instead of this ratio, then you can use 2 and 8 if you want, or if you say I'll use 3, then the diameter on the ram will be 4 times as that, which will be 12. So whichever value you choose for the plunger, make sure that this ratio remains relevant to that calculation. However, if you do not want to think too much, just take the ratio that has been given. You say our diameter on the ram, I'll use 4, you square over 1 square, and this becomes much easier because you're not dealing with actually 2 huge numbers. But if you want, you can use 3 and 12, and or whichever value. If you use 4, then that will be 16, but whichever value that you get. What we have is that the force is 4,000 newtons, okay, which is basically what a machine does. A machine, we apply a small amount of force, we get out a big amount of force. So this basically is a good machine that is helping us do a lot of work. We can even calculate the mechanical advantage of this machine. We'll take our 4,000 divided by 250, then it will give us the advantage of this hydraulic press. The next question says calculate the diameter of the plunger piston. So what we have is that we have the volume that is displaced by the plunger. We are not given the area, we are not given the diameter. We're actually calculating for the diameter. So what we know is that volume is equals to the area times the height, but in this case we do not need the area, we need the diameter. So volume is equals to pi times the diameter square over 4 times the height. We have our stroke length, which is 50 meters. We have our volume, which is that. So what we are calculating for is the diameter. We cross multiply. What we'll find is that diameter is equals to the root of 4 times volume over pi times h, the stroke length, which is already given. So now we'll say 4 times our volume, which is 35342,917 over pi times our height, which is 50 millimeters. Now, in most questions, please be very careful with the prefix values of everything that has been given. With my calculations, my volume is in cubic millimeters, so I have no problem with that. My stroke length is also in millimeters, so no need to change those two values. But however, in other questions, you need to take extra care and look out for those calculations. If this was in centimeters, then it will not correspond with the cubic millimeters, so they have to be in the same units. If you're dealing with millimeters, everything should be in millimeters or cubic millimeters. If you're dealing with centimeters, everything should be in centimeters. So in this case, what we are getting is 29,9999, which is equals to just 30 millimeters, and our answer is also going to be in millimeters. The next question reads as follows. The following data refers to a single acting press, plunger diameter 80 millimeters, plunger stroke 120 millimeters, the ram diameter 300 millimeters, and this has got a slip of 5%. So there is a slip in this hydraulic press of 5%. Then the question, calculate the volume of liquid delivered to the ram per stroke. The other question reads, the distance moved by the ram after 5 pumping strokes. Alright, so for the first question, we are just asked the volume per stroke. Volume is equals to pi d square over 4 times the height. Now the volume, this should be the diameter of the plunger, this should be the stroke length. So we have the diameter of the plunger. Let me use a capital letter D since I've written a capital letter D there. Don't forget to square or write capital letter H on that. So we are just asked how much is delivered per stroke. So that is what we are going to do. Pi times diameter 80 square over 4 times our 120. Okay, what we'll get is 60318.789.5, or you can say 78.78, but this is cubic millimeters. Okay, the reason why we are saying cubic millimeters is because our 80 is millimeters, our 120 is also millimeters. What we have is cubic millimeters. Now, this does not give us the full answer because we have not considered our slip. So the volume slips, or the liquid slips out, and 5% of this will slip out. So we are not actually receiving this, we are actually receiving 5% less of this. 5% less of this is that we are only remaining with, if from 100% we lose 5, we are remaining with 95%. That is what is remaining. So we'll say 95% of this, that is what will remain with, that is what is delivered, because 5% slips out and 95% is what we remain with. So what you will do is you multiply this volume that we have multiplied by 95 over 100. How do we come about with the 95? We say 100 minus 5. This is what we remain with. We remain with 5%, and we get our answer 573,026,5 cubic millimeters. All right, so this is how slip comes in, and this is how we deal with slip. We can, however, if you want, you can involve the 95% right from the start of your calculations, or you can work with it as if it is an ideal machine, like we did. From this point up to that point, we dealt with it as an ideal machine with no losses. Then we applied the loss or the slip, we applied it at the final answer. And that is what I encourage, that whenever we have to deal with a loss or a slip or even efficiency, first work with it as an ideal machine, as if there is no losses, as if there is no slip, and then at the end of your calculations, that's when you can deal with the slip and the losses, just to avoid any confusion in your calculations. All right, the second question says the distance moved by the ram after 5 pumping strokes. After 5 pumping strokes, so how much will the ram go up? So just a quick reminder, this is what we have. We push this one down, this amount of liquid is received on this side. This guy goes up by this amount of volume to go up. Now after 5, this amount of liquid 5 times, this will be the amount of liquid that will fill up on this ram side. 5 times the amount of this liquid will fill up that volume. So what we do is, so what we are going to do in calculating for the displacement, we are going to take our volume. This is the volume per stroke, 573,026,5. We'll multiply it by 5, by the number of strokes that we have made. We have displaced this amount of liquid 5 times, and this, if we multiply this by 5, it gives us 2865132,5 cubic milliliters. So this is the volume that has been displaced 5 times, and this volume will lift our ram upwards at a certain height on the receiving side. So this volume has now been transferred to the ram, and this is the total volume that has gone to the ram. So what we say is that volume is equals to pi d square on the ram over 4 times the height. We have our volume, we have our diameter, this 300, and we are looking for our height. We change the subject of a formula. What we have is that our height on the ram will be equals to 4v over pi d square. All right, so our diameter is already given, is 300. Our volume is what we have, so we can calculate for this and say 4 times 2865132,5 over our pi times our diameter. Now we'll take the diameter of the ram, not the diameter of the plunger. We are done with the plunger. We just use the plunger on this side, but in this case we are now considering the ram side, and also do not forget to square the diameter because it's squared in there. And our height, the stroke, the height to which our ram will go up will be 12160 millimeters. Our answer will be in millimeters because whatever we have been using here, we've used cubic millimeters, we've used millimeters for the diameter of the ram, and that gives us our answer. Now for the final practice question in this video, this question reads as follows. The diameter of the ram of a hydraulic jack is 115 millimeters and the diameter of the plunger is 30 millimeters. The mechanical advantage is 15 and the stroke of the plunger is 28. So this is what we have. We have the diameter of the ram is 115 millimeters. Diameter of plunger is 30. The mechanical advantage is 15 and the stroke length of the plunger is 28 millimeters. Okay, so like we said, mechanical advantage is just a number, no units for mechanical advantage. Alright, so it says calculate the effort applied to the handle required to lift a mass of 1.5 tons. So we are supposed to lift a mass of 1.5 tons if the efficiency is 87%. So this mass is being lifted at the ram. So with this we can calculate the ram force that we need to lift. With force or the weight of this, what we are going to say is that the force at the ram will say 1.5 tons times 1,000, so that we convert the 1.5 tons to kgs, times 9.8, so that now it becomes a force and becomes a weight. And what we have is 14700 newtons. Okay, so the reason why we are turning this mass to a weight is because remember what we are dealing with is we are dealing with force on the plunger over diameter of plunger should be equals to force on the ram over diameter square on the ram. We are dealing with forces, we are not dealing with masses. So it is important that we change that mass to a weight. You change a mass to a weight by multiplying by 9.8, then it becomes a weight. So this 14,700 is the weight on the ram or the force on the ram. Alright, so now the question is asking us how much force will be applied on the handle, or how much force will be applied on that side of the plunger so that we can lift this. So like I said, always deal with it as a perfect machine. We will deal with this at the last stages, and also that efficiency that has been mentioned of 87%, we will deal with it at the end. As at now, just deal with it as a perfect machine with no losses, no mechanical advantage and so on. Let's calculate for the force on the plunger. So we cross multiply, or you throw everything in there. What we have is that force on plunger is equals to your force on ram times the diameter square of plunger over the diameter square on the ram. We have our force 14,700 times the diameter of the plunger 30. You square the diameter of the ram 115. You also square that. What we'll get is 1,000,378 newtons. Okay, so now this 1,000,378 newtons, this is as if the machine is perfect, but what we know is that there is an efficiency of 87%. What that means is that if you apply a force of 1,000 and 14.378 newtons. You apply that force on this side. On this side, we are supposed to lift 14,700 newtons. This will not be enough because if you apply this, about 13% of this is lost. So it will, whatever that is received on the ram side will not be sufficient to lift this force upwards. What you need is that now we are considering the efficiency of our system, how good this system is. What we are saying is that this 1,000 and 1,000.378 will not be enough because there will already be a loss that will occur in the same process as the machine is trying to work. So what we will say is to consider this efficiency in our calculations. Now what we said is that efficiency is a ratio between the out over the in times our 100%. We have our 87%, that is our efficiency. What we need to get out at the end of the day, we need enough force to remain after we consider. So we need this 1,378 over our in, how much force we need to apply, times 100. Okay, this is 100 on that side. All right, then we cross multiply and so on. What do we find? To make life easy, instead of us going through all this amount of work, what I usually advise is that you need to think very hard when it comes to applying efficiency. You need to know, where are we working from? If we look at this, we are working from the ram side going to the force that we need to apply. No matter what happens, this 14,700 needs to go up. So we cannot apply the 1,000.378. We need this force, enough force to go up. We need to increase this. So if we need to increase this, the easiest way, instead of us doing all of these calculations, I usually advise that you just multiply this 1,000.378. You multiply by, instead of saying efficiency, it's a percentage, you say 100 over 87 and it will give us our answer. This part skips all of these calculations where you have to consider the efficiency and output over input, because most students tend to confuse themselves between which one is my output, which one is my input. So then they'll get mixed up and lose their calculations. But before you apply the efficiency, what I advise is you ask yourself at this point, what are we doing with this 1,000? Do we need to increase it or do we need to reduce it? If we need to increase it, then you invest the 100 over 87. If you need to reduce it, and that is when you're working from this side going to that side, you will need to reduce it. You already have the force, how much force is received there after the losses have occurred. But in this case, we need to increase, so it will be 100 over 87. It's the same. If you look at these calculations, you'll notice that 1,000.378 is multiplied by 100. That is what we have then divided by 87. And our answer that we get is 8598 newtons. Okay, so we have increased this force slightly higher, and at this point we are a step away from finishing our answer. The next step is now considering what? Our mechanical advantage. So now remember what I said is that you do them step by step: mechanical advantage, efficiency, or you can start with your mechanical advantage, then you do your efficiency at the end. For me, I chose to deal with the efficiency, then the mechanical advantage at the end. So with the mechanical advantage, what we are saying is that mechanical advantage is a ratio between the load over the effort. Mechanical advantage is just a number 15 that has been given to us. Our load will take this value. They are asking us for our effort. You cross multiply. Our effort is equals to the load over the mechanical advantage. So we'll be taking our load, the 1149,8598, Usually we leave our answer to 3 decimals, but I'm just doing that, so it's still fine. Divided by our mechanical advantage, which is 15, and we get our answer as 76,657 newtons. So this will be the effort that we will need to apply on the ram side, or on the lever of the ram. So that is what we'll be doing. So I advise your first step, work with the machine or the press as if it is a perfect machine all the way up until here. After we deal with it as a perfect machine, then we consider, this will be our number 2, we consider our efficiency, or you can consider the mechanical advantage. The second step is up to you. And then in our calculations, we consider the mechanical advantage as our last step. So, but it doesn't matter which one you choose, but just to avoid getting confused in your calculations, I advise that you deal with it step by step. Deal with it as an ideal system, apply either mechanical advantage and later apply your efficiency, and then your calculations will be good to go. The last part of the question reads as follows: calculate the number of strokes required to lift the load 50 millimeters if the slip is 7%. So the height on the ram is 50 millimeters and there is a slip of 7%. Again, we will deal with the 7% at the end of our calculations. We deal with this machine as a perfect machine. So our height on the ram is 50 millimeters. That's what we are calculating for. Number of strokes is equals to the volume that is received on the ram over the volume that is displaced at the plunger. In this case, we know volume is equals to pi d square over 4 times the height. So if we say volume of the ram, pi times the diameter of the ram square over 4, then we multiply by the height. Then everything, the plunger side, pi times the diameter square of the plunger over 4 times the height of the stroke length of the plunger. Pi and 4 will divide themselves out. What will remain with is just pi d square. Pi and 4 divide themselves out. So we have the diameter square of the ram times the height of the ram over the diameter square of the plunger times the stroke length of the plunger. Then this becomes much easier for us to calculate. So if we substitute, what we'll be saying is the diameter that was given, the diameter of the ram 115 millimeters, you square times the height that you are aiming for, the height of 50 millimeters, divided by the diameter of the plunger 30, you square times the height, the stroke length, which is 28. And when we calculate this, it gives us an answer of 26,24 strokes. Okay, now it gives us the answer of 26,24 strokes. Now this 26,24 strokes is as if the machine is perfect, as if there is no slip. But what we want is now to consider our slip of 7%. Now a slip of 7%, this is a loss. So in order for us to know how many strokes, if we do 26,24 strokes, we will not reach the 50 millimeters. So we need to do more strokes so that as the 7% loss happens, we will still reach our 50 millimeters that we are aiming for. So our last step, we'll take the 26,24 strokes multiplied by 100 over 93. The 93% is because we have minus the 7%. We need to increase this like we did with the 87% efficiency. We do the same with this 100 over 93 because we need to increase to the number of strokes in order for us to reach the 50 millimeters that is required. So if we do that, our final answer will give us 28,215, and these are just strokes. How many strokes are required to reach that amount that is required of 50 millimeters? and that basically gives us our calculations, and we are good to go. All right, hopefully you found this calculations or this video helpful, and all the best in your studies.